Welcome back to solving systems of equation by elimination. We have two problems here that we want to take a look at, two systems actually, and we'll probably do these in part 1 and part 2 because of the 15-minute rule. But let me give you some information here. Sometimes, or let's say in some cases, you may first need to multiply one or both of the equations by a number so that one of the variables have opposite coefficient. Remember, this is what we are trying to do here when we are looking at elimination. We are trying to make sure that one of these particular variables have opposite coefficient. So let's just go ahead and take a look at the first one, and then we'll talk about what we'll do as far as steps are concerned. Again, it's not anything really devastating. It's just going to take it's a little time consuming. So hopefully that you guys will develop the patience and we can be able to work through these. Okay, so as we look at this, and remember we said that step 1 is that we need to write them in sequence where they're underneath each other. So let's go ahead and add something special to this first step. Okay, so not only are we going to write them where each term is underneath each term, but we're going to be able to, we want to look at it and determine what's going on with this term and what can we do with this term to make sure that it's opposite actually. So we have 3x plus 2y is equal to 6. And here we have a negative x, and this negative x is plus y is equal to a negative 2. So as you look at these guys, if you look at it, and let's just be really deliberate with this, while I'm watching the clock, but let's just be really deliberate with this. We can do something here because 3 and 1, negative 1, they're not opposite, and then 2 and 1 is not opposite. But we can look at either one of these and determine what can we do. First, we can look at the second, and we can multiply the second one by 3, everything by 3, and that will give our x values opposite. Or we can multiply the second by a negative 2, and that will give our y values the opposite variable. So let's just, since we can see this, let's go ahead and multiply by 3 the second term. Okay, so we're multiplying every single thing, every single term by 3. Okay, so this will give me 3 times a negative 1. That'll give me a negative 3x plus 3y is equal to a negative 6. Okay, and then all I need to do is bring down this first term, which was 3x plus 2y is equal to 6. Okay, so now I need to look at my second step, which is to simplify and add the equations. So here, negative 3 is going to give me 0 plus, and I have 5y is equal to, and 6 and 6 is 0, so that'll give me 5y is equal to 0. And I'm going to divide everything by 5, not y. Divide everything by 5. and that'll give me y is equal to 0. Now what I can do now, according to step 3, is to substitute 0 in for y and solve either one of the original equations. So let's go ahead and take the first equation. So this is step 3, and I'm going to substitute 0 in for the first equation. So that'll be 3x plus 2y is equal to 6. Alright, so we said y is 0, so that'll be 3x plus 2 times 0 is equal to 6. That'll make that 3x is equal to 6. Divide both by 6 by 3. Okay. And here x is equal to 2. So our step 4 tells us to write our ordered pairs. So our ordered pairs is 2, 0. Now we just need to check. Okay, and we will check by adding our ordered pairs, and let's just take the first equation, which is 3 times 2 plus 2 times 0 is equal to 6. 3 times 2 is 6 plus 0 is equal to 6, and 6 does equal to 6. Okay, so it checks for the first one, and let's take the second equation without the 3. So we're going back to the original equation, which is a negative x plus y is equal to a negative 2. So we know that x is 2, so this would be a negative 2 plus y is 0 is equal to a negative 2, and indeed a negative 2 is equal to a negative 2. So again, that one checks as well. So as you can see, and like I said, I think I'm going to do this in a 2-part where we can look at this separately. But as you can see, that once we were able to identify a variable that we could easily turn into an opposite, then we just follow the regular steps of elimination and go ahead and solve the actual system. Okay, so we will come back for part 2 of this and work the second equation.